All right, starting off with a do now here. Going back to what we did the other day with the function notation. All right, instead of having an equation, this entire graph is f of x. So the other day it was find x, plug in, get y, find y, set it equal to, and solve for x. This is similar in a sense, but we're just completing points. So what we have here is an x of -2. So on our graph, when x is -2, we look down there and we have a y of -5. So f of -2 is -5. The 2 in front tells us the double for the overall answer being -10. All right, similar idea here. Y is -1. If I look on my graph and I scroll across the line y equals -1, I see that I hit the graph at 3 spots. Those 3 spots are 3 different x values that have a y value of 1. So in this scenario, f of x equals -1 when all 3 of those x values actually work. F of -3 down there, so when x is -3, y is -3, and that 2 in front tells me to double it. F of 4, right? When x is 4, y is 0, giving us our overall answer of -6. All right, so similar to what we did the other day, no graph, no equations, just looking at a graph. And don't take the time and make the equations for this graph, each 4 pieces. That's crazy. Just look at the graph, complete the points, and you'll be fine. Now today's new thing is a system of inequalities. Now a system of inequalities is a little bit more straight to the point versus a system of equations. Equations, you're looking to get a 1-point answer, or maybe you have a no answer, maybe you have multiple infinite amount of answers. System of inequalities, we don't actually have to get a numeric answer. It's a visual answer for us. So the first thing, when graphing, the equal to's are going to be solid lines. The less than greater than will be dotted lines. All right, so I'm graphing line 1, 4, up 5 over, down 5 over, and it's going to be dotted line in this scenario because it's a less than. Y is less than 2, dotted line cutting across at y equals 2. X is greater than or equal -4. All right, so in this situation, solid line coming through because of the greater than or equal 2. And the last one, understand here, we have a slope of 1/2, and it gives us a point of 2, -3. A lot of people always want to get stuff into y equals form, which isn't wrong here, but this does give you a point. You can go to 2, -3, and from there go up 1 over 1 and get your entire graph without necessarily needing to find your y-intercept. And that will have a solid line. So the next thing to consider is with shading. All right, so with a number line, it was shade left or right. With x and y coordinate plane, we're talking about shading above or below. So the less thans, that's going to be shade below, while the greater thans, that's going to be shade above. So what I do is I put some little marks here. Now, before I jump to it, it doesn't matter what type of line. If you have a positive sloping line, below is underneath it. If you have a negative sloping line, below is still underneath it. It's not left or right shade, it's above or below. So with our first one, y is less than -5x plus 4, I'm shading under the line. Y is less than 2, under the line. Now with a vertical line, it's not, you can't be above or below, just thinking logically. X is greater than or equal -4. What numbers are greater than or equal -4? Numbers like 0 and 10 and everything to the right. With the last one, just because I want to make sure there's no sign flip, it's not going to happen here, but down the road it could happen. All right, so no sign flip, got my y equals formula, and I have in this situation, a greater than, so I'm going above. So with all my little arrows out there, in the end, I see that my answer is in there. That yellow is the answer. Technically speaking, the problem is done. You don't have to go any further, right? Solve the system of inequalities, the yellow, that is the answer, done. Now, we're actually going to take this a little bit further just because I want to kind of touch on what's coming up next week. And that's when we're going to talk about corner points. Right? The system of inequalities, it is done. Done. There's our answer. But corner points bring on what's happening next week. All right, so solid corner points come from two solid lines. So we only have one solid corner point there. An open corner point has to have one dotted line, or I should say at least one dotted line. So all of these end up being open. All right, and the way this ties into our current unit of systems is at each corner point we can solve the system. So point A, there's not much to solve. Point A, we have the point negative 4, 2. Point B, we have y equals 2 crossing with y equals negative 5x plus 4. So when I'm solving the system, I just make them y equals. I don't have to make them inequalities, because at that spot, they're two lines crossing. So 2, negative 5x plus 4, subtract it over, negative 6, negative 5x. In this situation, not negative 6, negative 2. Negative 2, x equals 2/5. Our corner is at 2/5, comma 2. All right, part D, I got x equals negative 4, crossing with y equals half x minus 4. If I plug in x, 1/2, negative 4 minus 4. In that situation, I get negative 6. So my corner there is at negative 4, negative 6. The last one's got a little bit of work going on. So I got y equals negative 5x plus 4, crossing with y equals half x minus 4. So me, I'm gonna avoid working with fractions. I don't want to deal with the half, so I'm gonna multiply the top equation by 2 and the bottom by negative 2. So that gives me 2y negative 10x plus 8, negative 2y negative x plus 8. So I got my system set up. 0, negative 11x plus 16, x equals negative 16 over 11, which then I can plug in. So, all right, y equals 1/2, negative 16 over 11 minus 4, y equals negative 8 over 11 minus 44 over 11. Oops. Keep making little errors here. That should be positive. All right, so I got 11 over 16, so I got positive 8, so then I get negative 36 over 11. So my coordinate there is 16, 11, negative 36 over 11. And these corners, they're great. We found them. They're there. They don't have any meaning yet. Down the road, they'll have meaning. The system of inequalities, that's the answer, the yellow. The system of the inequalities with corners doesn't have a meaning yet. All right, so over here, just doing the graph with you. All right, so I'm going to make this into my y equals form. 2y is less than negative 3x plus 6. Y is less than negative 3 over 2x plus 3. Got my dot there. I'm going down 3 over 2, down 3 over 2, and the reverse. And in this situation, I got my dotted line because we have a less than. Over here, negative 2y is less than or equal to negative x minus 4. Divide by negative 2, sign flip, half x plus 2. And this will be a solid line due to the inequality that we have. The last thing, if you want for this one, you can actually take this and separate it. You can make it x is less than negative 2, and you can make it x is greater than or equal to negative 4. Right, I think about it's kind of like a train track in this scenario. You got a vertical line cutting through at negative 4, and you have a dotted vertical line cutting through at negative 2. Right, so they make a train track idea. All right, where is our answer? So we are above this line. We are below this line, and we are in between the train tracks. So our answer, it's in there. Technically, if we look, we got a solid corner, we have an open corner, an open corner, and an open corner. All right, they don't mean much, but down the road they will, but the yellow's our answer. Now I got a question like, is it always gonna be surrounded? Technically no, like if we have two lines crossing this way, if their shade is this, technically that shade with two lines going forever, the shade is also going forever at one corner point. And that's fine for that situation. You might have a situation where you have no shade, so you have no corner point.